Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Interdisciplinary and Trans-Disciplinary Studies, SOITS, Certificate Postgraduate Certificate Programs, Postgraduate Certificate in Climate Change, PGCCC MEV 0 to 4 Climate Change Assessment Tools, Block-1 Vulnerability Assessment, Unit-1 Climate Change Vulnerability Assessment, 1.1 Introduction. Vulnerability is an important concept in climate change discourse. Vulnerability is defined as the degree to which a system is susceptible to or unable to cope with adverse effects of climate change, including climate variability and extremes. Vulnerability is a function of the character, magnitude, and rate of climate variation to which a system is exposed, its sensitivity, and its adaptive capacity. IPCC 2001. In other words, vulnerability is a product of the sensitivity of a system to changes in climate, adaptive capacity, and the degree of exposure of the system to climatic hazards. Further, it can be stated that a highly vulnerable system would be a system that is very sensitive to modest changes in climate, where the sensitivity includes the potential for substantial harmful effects and for which the ability to adapt is severely constrained. In this unit, you will be learning about the fundamentals of vulnerability and methods for analyzing vulnerability. 1.2 Objectives. After studying this unit, you should be able to Z. Explain vulnerability and Z. Describe methods for analyzing vulnerability. 1.3 Vulnerability. The vulnerability is conceptualized by Intergovernmental Panel on Climate Change as a function of the state of social systems and the nature of biophysical climate change effects which they face. IPCC 2007. Vulnerability is a function of the character, magnitude, and rate of climate variation to which a system is exposed, its sensitivity, and its adaptive capacity given the inherent adaptive capacities that exist in those systems. Brooks 2003. So the vulnerability of any system squarely depends on the adaptive capacities of the system and also on the potential of system to cope with the impacts. Vulnerability is defined as a function of a range of biophysical and socioeconomic factors, commonly aggregated into three components that includes an estimate of adaptive capacity, sensitivity, and exposure to climate variability and change. Nevertheless, Intergovernmental Panel on Climate Change in its 4th and 5th assessment reports categorically defines vulnerability as a function of exposure, sensitivity, and adaptive capacity. In fact, the three components with exposure, sensitivity, and adaptive capacity enable to define and determine the system's vulnerability to climate change and further provide insights both for assessing and minimizing the threats of and risks associated with climate change. Exposure refers to the degree of climate stress upon a particular unit of analysis. Further, the climate stress refers to either climate change, long-term change in climatic condition, or climate variability, which includes the extreme weather events like drought, floods, etc. IPCC 2001. Climate exposure indicators include temperature rise, heavy rain, drought, and sea level rise. Ludena and U. 2015. Exposure is perhaps an amalgamation of biophysical dimension and social dimension. As regards the second component, sensitivity of the system, IPCC 2001 defines sensitivity as the degree to which a system will respond to a change in climate, either positively or negatively. The degree of a system's sensitivity to climatic hazards depends not only on geographic conditions but also socio-economic factors such as population and infrastructure. Eventually, the indicators of sensitivity include but not limited to geographical conditions, demographic attributes, land cover and land use, and economic activity like agriculture, nature-dependent activities, and industrial activities. Adaptive capacity describes the ability of a system to adjust to actual or expected climate stress or to cope with climatic extremes. Normally, adaptive capacity from the perspective of climate change, stress depends mainly on the physical resources. Physical infrastructure, economic factors, access to technology, information, resources, etc. Hence, the indicators for adaptive capacity encompasses the physical infrastructure, socio-economic, capital, economic capability, institutional capacity, and data availability. For instance, the economic capability refers to the economic resources that has the potential to greatly minimize the vulnerability of the system to climate stress or hazards. Further, it encompasses the social and human capital and the technological developments as well. Key indicators of institutional capability include the political leadership, climate policy and climate governance, disaster prevention and risk reduction. Systems. As regards the social capital, the indicators are social network of individual know-how and mutual trust to cope with climate impact, Ludena and U. 2015. It may be stated at this juncture that vulnerability may also be viewed from the outcome and contextual perspective. The vulnerability concept has been used widely in the domain of economics, climate change studies, and disaster risk reduction. Perhaps the multi, inter, and transdisciplinary approach inherent within the vulnerability concept and analysis squarely led to its constant evolution, sterling importance and of course, to its complexity. 1.4 Conceptualization of vulnerability. The use of the term vulnerability in many disciplines had paved way for emergence of intriguing questions: Z. Whether vulnerability is the starting point, an intermediate element, or the outcome of an assessment. Z. Whether it should be defined in relation to an external stressor such as climate change, or in relation to an undesirable outcome such as famine. Z. Whether it is an inherent property of a system or contingent upon a specific scenario of external stresses and internal responses, and Z. Whether it is a static or a dynamic concept. Fussell and Klein 2006. In spite of the ambiguities and diversity, few frameworks emerged in the literature. The risk-hazard framework conceptualizes vulnerability as the dose-response relationship between an exogenous hazard to a system and its adverse effects. The social constructivist framework prevailing in political economy and human geography regards social vulnerability as an a priori condition of a household or a community that is determined by socio-economic and political factors. Another framework, integrated framework, considers vulnerability as an integrated measure of the expected magnitude of adverse effects to a system caused by a given level of certain external stressors. This line of thought is widely adopted in the global change studies, in particular the climate change studies. According to this framework, vulnerability encompasses two dimensions, with an external dimension, exposure, of a system to climate variations, and an internal dimension, sensitivity and its adaptive capacity to these stressors. Fussell and Klein 2006. In the recent past, the concept and measures of vulnerability have been gaining importance in the interdisciplinary research-intensive climate change studies to decipher the complexity of the science of climate change and to elucidate the degree to which a system, socio-economic and environmental systems, suffers from climate change stress. Vulnerability measures during the initial period of theoretical development have been based on the simulation studies on economic losses due to the impacts of climate change on the biophysical environment. Nevertheless, through the lens of socio-economic dimension. The focus of vulnerability studies have been on the sensitivity of the system to climate change and also on the resilience capacity of the community to cope with the climate change stress. At this juncture, the importance of adaptive capacity and adaptation strategies must be highlighted as they play a significant role in augmenting the resilience of the system. Vulnerability is a relative property. It refers to a potential event. Conceptualizing vulnerability from the perspective of climate change is indeed a challenge. Climate change effects on the sector and society are complex, and the effects are differential for the reasons such as the geographical feature of a location, differences between regions and between groups and sectors in society, and the adaptive capacity. This line of thought may be distilled and stated as the concept of vulnerability is a relative one. It is the vulnerability of an entity to a specific stimulus and with respect to certain preference criteria. In effect, the three underlying factors of vulnerability are entity, stimulus and preference criteria. IGNOU et al. 2005. In the mathematical framework proposed by the IGNOU and co-workers, 2005, the three primitives, namely the entity, the stimulus, and the preference criteria, are stated to be essential to conceptualize the vulnerability paradigm. Fussell, 2007, endeavored to describe a vulnerable situation with the help of four dimensions, namely the system, attribute of concern, hazard and temporal reference. The system of analysis encompasses among others the coupled human environment system, natural system, social system, an economic system, a population group, or a geographical region. The examples of attributes of concern include but not limited to human lives and health, the cultural identity of a community, the biodiversity, carbon sequestration potential of a forest ecosystem. A hazard is construed as an event, phenomenon or human activity that may adversely affect a valued attribute of a system. Next to the description of the vulnerable situation, it is pertinent to know about the vulnerability factors. In fact, four groups of vulnerability factors were proposed by the United Nations body in the context of disaster risk reduction. The factors are physical factors, economic factors, economic resources of individuals, populations, groups, and communities, social factors, the level of education, security, access to basic human rights, and good governance, and environmental factors. As regards the vulnerability factors, sphere or scale and knowledge domain are the two dimensions of vulnerability. Dovetailing the virtues of vulnerable situation, vulnerable factors and dimensions of the vulnerability, Fussell, 2007, proposed a conceptual framework of vulnerability with 6 dimensions. With temporal reference, current versus future versus dynamic, sphere, internal versus external versus cross-scale, knowledge domain, socioeconomic versus biophysical versus integrated, vulnerable system, attribute of concern and hazard, Fussell 2007. 1.5 Approaches to vulnerability research. Vulnerability studies can be grouped into two categories with contextual approaches, bottom-up or starting point vulnerability, and outcome approaches, top-down and endpoint vulnerability. The former approach focuses on the factors that drive the system's ability to withstand and cope up with the stress. Basically, the contextual approach have been applied to gauge the vulnerability of human systems to climate stress and weather extremes by factoring in the contextual factors that indeed affect the system. On the other hand, the outcome vulnerability approach reflects an integrated concept that combines both the potential climate impacts and socio-economic capacity to understand and assess the vulnerability. The approaches to vulnerability research discussed in the following sections were mainly sourced from the work of Hans Martin Fussell, 2007. Risk hazard approach. The risk hazard approach is commonly used for assessing the risks associated with hazards of a particular type and magnitude. This approach is used to decipher the vulnerability of physical systems to hazards. Hence, it is quite common with engineers and economists who embark on vulnerability analysis. The risk is a product of hazard and vulnerability. The hazard is a potentially damaging physical event, phenomenon or human activity, and the hazard is characterized by its location, intensity, frequency, and probability. On the other hand, the vulnerability comma, which denotes the relationship between the severity of hazard and the degree of damage caused. In this approach, the vulnerability is construed as an internal, biophysical vulnerability. Political economy approach. The political economy approach endeavors to figure out the vulnerable people and to find the reason for their vulnerability to stress. The vulnerability definition of Ajar and Kelly, 1999, resonates with this approach. Vulnerability is defined as the state of individuals, groups or communities in terms of their ability to cope with and adapt to any external stress placed on their livelihoods and well-being. The vulnerability is influenced by the factors such as the resource availability, entitlement of individuals, etc. In other words, this approach focuses on the socio-economic and political status of individuals or social groups and on identifying the adaptive capacity of individuals or communities based on their internal characteristics. The socio-economic background of individuals and community influence the vulnerability levels. For instance, the factors like educational background, income and wealth, health, gender equality, accessibility to resources greatly influence the vulnerability levels. In this approach, it is presumed that the vulnerability persists in the system before actually the system faces the stress. In effect, the vulnerability is a social construct and they are the product of socio-political and economic landscape of the society. For instance, the vulnerability of fishing community to climate change-induced coastal hazard is driven by multitude of factors which are socio-political in nature. Nevertheless, this approach has few limitations. Non-inclusion of environmental factors. Natural resource base are considered as limitations of this approach. Integrated assessment approach, the risk hazard framework and the social constructivist framework have been combined in the integrated framework. The example of integrated approach include the hazard of place framework. In this approach, vulnerability exemplifies the characteristics of both vulnerable social unit and the biophysical stressors. In other words, this approach typifies the integration of the internal factors of a vulnerable system with its exposure to external hazards. The vulnerability is defined as the likelihood that an individual or group will be exposed to and adversely affected by a hazard. Cutter et al. 1993. This approach finds currency in assessing the health risks from climatic events, especially extreme weather events, and in the studies pertaining to food insecurity and disaster. Further, integrated assessment approach is used in climate change studies to assess the vulnerability of a region or community to climate change. This approach is used in the vulnerability mapping wherein GIS tools are used for figuring out the vulnerable regions. 1.6 Methods for analyzing vulnerability. Few methods for analyzing vulnerability are discussed in this section. Econometric method. The econometric method takes into account the household-level socioeconomic survey data to gauge the vulnerability of different social groups in the society. The welfare loss due to shocks are contemplated for vulnerability measurement. This method mainly encompasses three categories viz. Vulnerability as expected, poverty, vulnerability as low expected utility and vulnerability as uninsured exposure to risk. As regards the expected poverty structure, vulnerability of an individual is a measure of the probability that the individual would become poor in the future due to the shocks. In this case, the income or consumption can be construed for measuring human well-being. This method demands cross-sectional survey to collect the socioeconomic data. The vulnerability as uninsured exposure to risk method is basically an ex post facto assessment of vulnerability. This method is based on the premise that the shocks result in the loss of welfare which can be correlated to reduction in consumption. In other words, the household needs insurance against the negative shocks and in fact the amount paid as insurance is equal to the amount of welfare loss incurred due to the negative shocks. Diresa et al. 2008. Indicator method. The indicator-based methods use a set of proxy indicators so as to produce measurable outputs across various spatial scales. This method is based on selecting few indicators from the mosaic of indicators and aggregating the selected indicators to quantify the vulnerability. Through this method, the vulnerability can be analyzed on varied scales viz from local to global scales through national and regional scales. This method is explained in the Unit 2 of the course MEV 0-4. Nevertheless, there are two options available as regards the vulnerability assessment through indicator method. It can be either assigning equal weights to the indicators or assigning unequal weights to the indicators. Diresa et al. 2008. This method is understood effortlessly by decision makers. As regards the applications, this method has potential to monitor trends and also the implementation of adaptation responses. The examples for this method are Livelihood Vulnerability Index, LVI, Household Adaptive Capacity Index, HACI, Well-being Index, HWI, and Index of Social Vulnerability to Climate Change for Africa, SVA. Vulnerability indicator can be defined as an operational representation of a characteristic or quality of a system able to provide information regarding the susceptibility, coping capacity and resilience of an element at risk to an impact of an albeit ill-defined event linked with a hazard of natural origin. Berkman 2013. Vulnerability indicators, besides aiding in vulnerability assessment, provide valuable information to policy makers to undertake pragmatic solution in the domain of climate change adaptation. For instance, livelihood security and diversification of livelihood form a pivot in assessing the social vulnerability. Further, the vulnerability indicators provide a snapshot of the drivers of adaptive capacity, which is essentially the hallmark of a resilient system. The choice of the indicators and their applicability in vulnerability assessment depend on the place, phenomenon of interest, problem, the level of the adaptive capacity of the system, etc. It is essential to choose an appropriate and indeed a smart indicator for vulnerability assessment. 1.7 Summary. Vulnerability is indeed a significant concept gaining currency in climate change science. Vulnerability is a function of the character, magnitude, and rate of climate variation to which a system is exposed, its sensitivity, and its adaptive capacity. IPCC 2001. The vulnerability is conceptualized by Intergovernmental Panel on Climate Change as a function of the state of social systems and the nature of biophysical climate change effects which they face. IPCC 2007. The multi, inter, and transdisciplinary approach inherent within the vulnerability concept and analysis led to its constant evolution, sterling importance and of course, to its complexity. Vulnerability of any system depends on the adaptive capacities of the system and also on the potential of system to cope with the impacts. Vulnerability studies can be grouped into two categories, with contextual approaches and outcome approaches. While the contextual approach focuses on the factors that drive the system's ability to withstand and cope up with the stress, the outcome vulnerability approach reflects an integrated concept that combines both the potential climate impacts and socioeconomic capacity to understand and assess the vulnerability. The conceptual approaches for analyzing vulnerability are socioeconomic approach, biophysical approaches, and integrated assessment approach. In this unit, we have discussed the fundamentals of vulnerability and methods for analyzing vulnerability like economic method and indicator method. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.